Ratios, I am actually going to need to zoom in if I can to fill in the notes. It seems very blurry again, but I don't really know what's going on. So a ratio is the comparison of two numbers. Just didn't like the way they looked. I'm going to try that again. Remember when we talked about rates, we said it was two different numbers with two different units, so it was like the amount of feet per mile, or the amount of seconds it took to go a certain distance, or whatever. Whereas this could be the amount of boys to girls, the amount of squares to circles. So it's not necessarily a rate that you would commonly think of. But it could be a couple of different options, and you have to pay attention to the order. The order is very, very important when you're dealing with ratios. So it could be part to whole. You see those circles above. We could say the filled amount compared to the total amount is 2 to 5. So notice the ratio could be written as a fraction. And the first number would be the top of the fraction, and the second number would be the bottom of the fraction. Or it could be that the unfilled amount compared to the total is 3 to 5. And you could have the actual words, the word 2 in between. Every single time when you read a ratio, if you know that that's the intent, that it's comparing two things, you would normally use the 2. Sometimes you could use the out of, because if it's out of the total. For the next one, we could be comparing part of a collection to another part of a collection. The filled to unfilled is 2 to 3. A lot of times you're going to see this colon. And again, the order is important. So the 2 is the filled amounts, and the 3 are the unfilled amounts. Or it could be the other way around, the unfilled amounts compared to the filled amounts. 3 to 2. Now notice, even though it's set up as a fraction, you would never, ever, never change this ratio to a mixed number. It's 3 to 2. You have to see the distinct numbers from the top and from the bottom. So you don't turn your ratios that are written in fraction form into mixed numbers. And the last set of comparisons we could have for this simple little diagram, the whole amount compared to the part. And this is the one a lot of people want to switch the order, because they're more often used to thinking about the part compared to the total because of regular fractions and decimals and percents. But we could say the total compared to all the unfilled would be 5 to 3. Or the total compared to the filled would be 5 to 2. So I try to mix up the format in there, just to get you used to seeing all the different notation that could be used. I had another thought. Oh, sometimes they won't specifically tell you what the total is. You have to do the computation to figure out the total. They might say, oh, there were this many girls in the class and this many boys in the class, so what's the number of girls compared to the total? You have to add up the girls and the boys. So you do have to pay attention to what they're asking for and whether or not any computations are needed. Or they might tell you all the class, there was like 23 kids in the class and 10 of them were boys. What's the girls to total, or girls to boys, or whatever, and you have to do the computation to find out how many girls there were. So any of the above notation is appropriate. And even if a ratio is written as a fraction, never turn it into a mixed number. And so now we have some real life uses. This first one was like a legit, I was watching a game on TV, and this is what happened. So at a Red Sox game, the scoreboard showed Red Sox had 9 hits, and the Blue Jays had 6 hits. Jerry Memmi said, we're out hitting Toronto 3 to 2. So was he lying? So raise your hand if you can explain whether or not saying that the 9 hits compared to the 6 hits would be accurate to say we're out hitting them 3 to 2. Okay.
Yes, because 9 to 6 is equal to 3 to 2, because if you take out 3 as a common factor, then
Mm-hmm. So it's basically Jerry Remy. Y'all know who he is?
No.
I don't think he's announcing anymore, because he had a relapse of cancer. He is? Oh. So he's a Boston Red Sox announcer, but he basically took his ratio and put it in simplest terms. A lot of times on commercials you'll hear that. 9 out of 10 dentists recommend da-da-da-da. They probably asked more than 10 dentists. They simplified their ratio. So, explain, similar to what we got from you, sir. No, he divided each amount by 3 to get the ratio. In simplest form. The next one is another realistic, real-life kind of use of ratio. The Museum of Science requires a student to chaperone ratio of 10 to 1. So how many chaperones would we need for 110 students? So go ahead and think about that. Think about your explanation. Who thinks they know how many chaperones we need if we had 110 students going to the Museum of Science? Yes, ma'am. You need 11 chaperones. How'd you figure that?
Well, I divided 110 by 10 because you need 10 students per chaperone.
Mhm.
That was 11.
So this is similar to the whole idea of proportions that we've been talking about, making two things, making them be equal to each other. So 10 to 1 would be the same as 110 to 1. And it would be 110 to 11 because you multiply the 10 by 11, so therefore you multiply the 1 by 11. So here you can do it with the whole unit rate, or that kind of is unit rate there. Rate table, cross products, or in this case you could just figure out what your equivalent ratio would be. That I'm going to go ahead and write down. We would need 11 chaperones because each part of the ratio needs to be multiplied by 11 to get 110 students. For 11 chaperones. After you've jotted that down, think about the last one. If girls outnumber boys 14 to 10, what's the simplified ratio of boys to girls, and what fraction of the students are girls? So once you've jotted that down, go ahead and think about the last one. The whole idea of you need to multiply by 11 to make it so that it would work out. The question was, on that second example, could we have said, therefore I have 11 groups of 10, therefore I need 11 chaperones for each group? Yep, that would work out. So if girls outnumber boys 14 to 10, what's the simplified ratio of boys to girls? So let's go with the first part first. Sorry. So if girls outnumber boys 14 to 10, what's the simplified ratio of boys to girls? Boys to girls. So they switched the order. The original ratio was girls to boys. Girls was the 14, boys was the 10. But now it says what's the simplified ratio of boys to the girls. So what would it be?
5 over 7.
5 to 7. And then what fraction of the students are girls? 7/12 of them. So to jot down an answer for that, I have in my thing, but you might have it thought up differently. simplified ratio of boys to girls is 5 to 7. Gotta be paying attention to the order. A lot of times that's where things get mixed up. Because the order of the ratio changed. And each number can be divided by 2. And for the second part, 14 over 24 simplifies to 7/12 of the class are girls. I guess we're going to circle there. Add boys plus girls to get total. So that's the big thing that oftentimes gets people confused is the order or whether or not it's talking about the total and if you have to do a computation. So you're going to try out some practice problems.